Here it is, our final section of the class. So this is our last little foray into geometry, and we're looking at area and circumference. So we're looking at the area of different polygons. So that's our first objective. Not all of the polygons that we talked about in the last section, just these four here. And then we'll end the section, and the class is lectures with areas and circumferences. And this is specifically of circles. So let's talk about our area formulas. So for a triangle, the triangle, it can be any type of triangle that looks like this. We make the 90-degree straight line down from the top vertex, and this is our height. The whole length down here is the base, and our area is then 1/2 base times height. Now this is of course easier if you have a right triangle because the height is the side there. And oftentimes you can split a triangle like this into two right triangles by making this vertical height and then calculating two areas or calculating one area. It's about the same amount of work. Next is our rectangle and our square. So for the rectangles, this is the height and this is the base. And the square, where this is the height and this is the base. The area for both of these is just base times height, or length times width, is how we say it a lot of times as well, but that's true for both of these. For the parallelograms, and this of course includes rhombuses. Rhombuses. We make a 90-degree straight down just like this, just like we did for the triangle. This is considered the height. The whole bottom is considered the base. And our area is, once again, base times height. And that's because if this is the area for the parallelogram, rectangles and squares are, by definition, parallelograms, so they should follow the same conventions in terms of area, because all the properties are the same. And the last area formula that we're going to look at is the trapezoid. So if this is our trapezoid, you can make a vertical height like this. You could do it on this side as well, it doesn't matter. This we call A up here, and this we call B. And our area is then 1/2 the height times A plus B. So the more complicated the shape is, the more complicated the area formula needs to be. Okay, so we're just going to work through some problems that use some or all of these formulas, and we'll do a couple basic ones, and we'll do something like this first one where it's a word problem. So this first one says, pathway around the library needs to be redone. The schools decided to use a brick pathway. Find the area of the path shown below. Then, if it takes 4 bricks to cover 1 square foot, how many bricks will be necessary to complete the pathway? So we need to add in some things here. Make sure that you add in some 90-degree angles so we know everything's 90 degrees. This distance here is 3 feet. This distance inside here is 6 feet. The distance inside here is 13 feet. And this distance down here is also 3 feet. So those would all be given to you. It's just easier to write them in than to type them in. So if we want to calculate the area, there's a couple ways you can do this. I'm going to show you one way, and then we'll talk about the other way that you could do. You may see the second way first, but we'll start with this way because, well, I'm in charge and I'm here. So if we look at this whole rectangle and continue this out like this, this distance here is going to be 3 plus 13 is 16 feet. And this distance here is going to be 3 plus the 6, which is 9 feet. Now, I know that my diagram here is not to scale. This looks almost the same as this, but, you know, forgive me for that. So then our area is going to be the big rectangle minus this small rectangle. And so our area would be 16 times 9 minus the 13 times 6. 16 times 9 is 144. 13 times 6 is 78. And so this gives us 66. Now area, something that we should add up here actually. Area is always units squared, whether that be feet or centimeters or yards or steps. Whatever your unit is, you're always squaring it because you're multiplying 9 feet times 9 feet, or 16 feet. So you 9 times 16 and feet times feet. That's not quite how it works, but you can think of it that way. So this is 66 feet squared. That's our area. Because we took the whole thing and basically cut out this section. And then it says, if it takes 4 bricks to cover 1 square foot, how many bricks will be necessary to complete the path? So we have 4 bricks to 1 square foot, or foot squared, and we need to multiply this by 66 square feet. The feet squared cancel, and we have 66 times 4, which gives us 264 bricks. And I like doing it this way, where you're canceling your units, because it always ensures you have the right units at the end instead of trying to guess. So if you set up your conversion factor 4 bricks to 1 square foot, you could even put a 1 here to remind yourself. It'll always make sure you get your units correct at the end. Now, I said there was another way we could have done this problem, and that's back up here in calculating the area. You can, of course, split this into 2 rectangles, one that would be 10 feet by 3 feet, and one that would be 3 feet by 9 feet. And you could do that area and add it together, and you get the same result, 66 feet. Whatever direction you like to go in, whatever feels more natural, whether you do the cutout method like I did, take the big rectangle, subtract out the missing space, or you split it into 2, you'll get the same answer. You could also split the rectangles here as well and do one long one and one short, which would be a square. So a couple different ways you can attack problems like this. Okay, our next example says, find the area of a parallelogram with height of 4 centimeters and a width of 8 centimeters. So I'm going to sketch out a parallelogram real quick. It doesn't need to be perfect. They told us the height is 4 and the width is 8. So that means our area is just 4 times 8, or 32. These are in centimeters, so this is centimeters squared. That's just a straight calculation using the area formula. We turn the page here. A little bit more complicated example. A small sailboat has a triangular sail that has a height of 5 feet and a base of 12 feet. If the sail needs to be replaced and the material needed costs $3.99 per square foot, how much will the material for the new sail cost? So, for fun here, we do a little boat. And they told us that this right here is 5 feet, and this is 12 feet down here. So our area, 12 feet, would be 5 times 12 over 2, because it's 1/2 base times height. And so this is 60 over 2, which is 30. This would be feet squared. And then times $3.99, and this is in dollars, per square foot. And so we would times this. Now, you're just going to put this in your calculator, feet squared, cancel. Remember, it's money, so once you get your answer, round it to 2 decimals. And when I enter 30 times $3.99, I get 119.7. Since it's money, we add the 0, and this is dollars. So our result would be just under $120 for that new sail. Now, I messed up here. This is an old problem, so we can just ignore this. Yours doesn't have this. This is the first problem we did. Your packet doesn't actually have that problem. So the next one we have is find the area of a trapezoid with a height of 13 feet, a top length of 32 feet, and a bottom length of 46 feet. So I draw myself a little trapezoid here. They've told me that this right here is 13 feet. The top length is 32 feet. The bottom length is 46 feet. My area formula is then 1/2 times 13 times 32 plus 46, or 1/2 times 13 times 78. And when you punch this into your calculator, 78 divided by 2 is 39, times 13 is 507, and this is feet squared is our area of that trapezoid. Okay, so a couple little examples here. 2 that were word problems, 2 that were just straight applications, so you can get an idea of how the formulas work. To wrap up this section, this chapter, and our lectures for the class, the area and circumference of a circle will be our final topic. So the circumference, since the circle doesn't have sides, the circumference of a circle is the total distance all the way around. So if you think about a circle, its center is here, its radius is r. If we take this point right outside the circle and we go all the way around, and you were to walk around the circle, that's your circumference. It's that distance that you would have to walk all the way around. The circumference is always given by a capital C, and it equals 2 pi times r, where r is the radius. Alternatively, since it's 2 times r, all the way across is your diameter, you can also have a formula of C equals diameter times pi. T is diameter. So 2 different formulas depending on what you have. If you have the diameter, you can use that. If you don't, you can use the radius, or you could, divide your diameter by 2 and then you just be multiplying by 2 again. Whatever you want to do though. The area of a circle is your total space inside the circle here. And that's always given by A equals pi r squared, where r is radius, once again. So unlike circumference, the area needs you to make sure you have your radius. So if you're only given diameter, you have to calculate that radius. So let's turn the page, and we've got 2 problems here that deal with circles. The first says, find the total trim to the nearest tenth of a foot that is needed to go around the window below. Now we have to add some information here. The first is that the bottom is 6 feet in length, and the side up to right here, where it starts to stop being curvy, is 8 feet. So the way that we want to tackle this problem is to split this into a circular shape and a polygon. So what you should look at is right here, right at that line, it stops being a circle. And if we were to continue this, we could continue this circle, pretend it's not so egg-shaped, and we'd have a full circle here. And we even know what that radius would be. It would be 3 feet. Because we know that the full diameter is 6 feet. So what we want is the distance from here to here. So while our circumference is, we're going to use pi d, what we really want is not the whole thing. We want to divide this by 2. And so what this really is pi r. And so that's going to be pi times 3, or 3 pi, and we'll come back to that. And then we look at this rectangle that we've created. That's a perfect 8 by 6. And so we know that this is going to be 8 feet over here. So the perimeter of the rectangle is 8 plus 8 plus 6. We don't need this side, this extra 6 that's over here, because that's not on the trim. Remember, we drew that line in. And so the total perimeter which we'll call P sub t, is going to be 8 plus 8 plus 6 plus 3 pi. Now there's two ways to handle pi. You can handle pi as approximately 3.14, or your calculator has a pi button, and this will be exact, and then round off to what it's told us to, the nearest tenth of a foot. The calculator knows I think it stores like 15 decimals of pi. So when we add this up, we get 8 plus 8 plus 6, which is 22, plus 3 pi, which in my calculator rounds off to the nearest tenth as 31.4 feet. There's some other decimals in there, but we're rounding to the nearest tenth, so we cut it off at 4 because there's no bigger numbers. So this is not feet squared because it's perimeter. There was no multiplication of feet times feet. We needed to use the circumference and a perimeter problem or perimeter formula from the polygons. So if you can understand this problem, there's no other circumference problem that you couldn't do. And our last example here is a problem about pizza. So it says, which is a better deal? A large pizza with a 16-inch diameter for $17.99, or two medium pizzas with an 8-inch diameter for $16. So the biggest thing here, I'm going to draw my little fake pizzas. The diameter here is 16, or we have two mediums that have an 8-inch diameter. So the biggest thing here is determining what property you should be looking at, circumference or area. So if we think about circumference, circumference is just the edge along the rim or the crust, and it just tells us how long around the crust is. It doesn't actually tell us how much pizza we're getting. Pizza is the inside. So that means we want area. Well, area is pi r squared. Our r, if diameter is 16, must be 8, and this is in inches. So our area of our 16-inch pizza is pi times 8 squared, or 64 pi. Our area down here, if these are 8 inches, then this is pi times 4 squared. And what we actually want is 2 of these, because there are 2 pizzas. The Joey special, for you Friends fans. So now, to determine what's the better deal, once we calculate this out, this is 16 or 32 pi. What we do is we take the dollar amount, $17.99, and we divide it by this area, 64 pi. We take the dollar amount for the medium pizza deal, $16, divided by 32 pi. And so when you punch this into your calculator, $17.99 over 64 pi, this tells us 0.089 with some decimals. Now, this is dollars up here. So this is 0.09, and this would be dollars per square inch. So for every square inch of pizza, you're only paying 9 cents. Whereas down here, this comes out to be 0.159, and since this is in dollars, we're going to round this to 2 decimals, 0.16. And again, this is per square inch, because this is in inches squared, just like this is, because this was an area. So for the large pizza, you're paying 9 cents per square inch. For the 2 medium pizzas, you're paying 16 cents per square inch. So that means that this is the better deal because you're paying less for square inches. And you're getting more square inches here. You're getting 64 pi versus 32 pi. So the large pizza is better deal. And this is a strictly numerical sense in the word better. Right? You get more and you pay less per square inch. Now, if you have 2 people that want 2 very different things, then maybe this isn't the right deal for you, but it is the better deal. It has the most value in it. Okay, so that's the end of chapter 15. That's the end of our lectures. And next up will be the final exam coming up quick.